Hi, I hope that every one of you are doing well. So in this video, I'm going to solve the problems of the week related to week number 8, 19th of February. Okay, you can find these a link to the PDF file of the questions below the video of Algebraic Identities Lecture 1. Okay, so the first question is that question A. It is given that A and B are real numbers, and we know that A is greater than B. We also know that A plus B is 4, and A times B is 1. We are supposed to calculate the following expressions. Square root of A plus square root of B, and then we're supposed to calculate A squared plus B squared, and then A minus B, A squared, A cubed plus B cubed, A to the 4 plus B to the 4, A to the 4 minus B to the 4, and then finally the fourth root of A plus the fourth root of B. Okay, so if you have already watched the video, we had a formula in that lecture. So what is inside the box to the power of 2 plus what is inside the circle to the power of 2 can be written as what is inside the box plus what is inside the circle to the 2 minus 2 times the box times the circle. Okay, so for example, if I want to answer the first question, if I replace my box with the square root of A, and if I replace my circle with square root of B, let us see what happens. So if I substitute square root of A inside the box, because of this power 2, I will get A plus, I replace the square root of B in the circle, because of this power 2, it becomes B. On the right-hand side, instead of a square, I put the square root of A, and instead of circle, I put the square root of B to the power of 2 minus 2 times, instead of box, square root of A, square root of B. Yes? But let us see, what do I have? Okay. A plus B is given 4. So instead of A plus B, I can put 4. This is exactly my question mark. So this is the question mark to the power of 2. And then this part becomes square root of AB. But AB is given to be 1. So this becomes a square root of 1, which is 1. So I have minus 2 times 1, which is minus 2. But I am looking for my question mark. So this means that question mark to the power of 2 is 6. When I move 2 to the left-hand side, it becomes positive 2. It becomes 6. And then, of course, if I am looking for a number with that property, I have this one to be plus or minus square root of 6. But I already know that the question mark cannot be a negative number, because square root, the output of any square root is positive. The output of the square root of b is also, I would say, non-negative. So if I add two non-negative numbers, the sum should be a non-negative number. So minus the square root of 6 is not acceptable. So it means that the answer to this is square root of 6. Okay. Now let us go to the next one. Of course, again, I can use the formula here, but this time, instead of replacing a square with the square root of a, I replace a square with simply a itself. So then this will read in this form. This becomes a squared plus b squared is a plus b to the 2 minus 2ab. Okay? But then it is very easy to calculate, because this is now my question mark. A plus b is given to be 4 and ab is given to be 1. So this becomes 4 to the 2 minus 2 times 1, which is 16 minus 2, which is 14. So what I got is that a squared plus b squared is 14. Yes. And then I go to the next step. Now I want to calculate a minus b. Okay, so what can I do is that I have a squared plus b squared is equal to 14. Then I add minus 2ab to both sides here. So then what happens? This becomes a squared plus b squared minus 2ab. On the right-hand side, I will have 14 minus 2ab. Yes? But you know that this becomes a minus b to the 2. It's quadratic pattern. So this becomes 14 minus. I know that AB is equal to 1, so this is equal to 1, so it becomes 14 minus 2, which is, of course, 12. And then my question mark is A minus B. So A minus B to the 2 is 12, so it means that A minus B is either plus or minus a square root of 12. But of course, a square root of 12 is plus and minus to a square root of 3. Yes? But it is mentioned in the problem that A is larger than B, so A minus B cannot be negative. So it means that the only answer which is acceptable in this case is, so since A is greater than B, A minus B cannot be negative. So the answer would be 2 square root of 3. Okay? Yes. Now I go to this one. Now I want to calculate A3 plus B3. Okay? If you go further and watch video number 3, then you will see that I have given a simple formula for calculating A cubed plus B cubed in that video. But in this lecture, I haven't talked about that, so I want to use the method that I introduced exactly in lecture 1. So if I want to calculate this, I would say that A plus B is given to be 4 from the beginning, and I have calculated A squared plus B squared to be 14. So I would write them. A plus B is 4, and A squared plus B squared is 14. So if I multiply both sides, then it becomes A plus B times A squared plus B squared is 4 times 14, which is 56. And then if I multiply that, this gives me A to the 3 plus AB squared plus BA squared plus B to the 3 is equal to 56. Then you can see that I can immediately write A3 plus B3 next to each other. And then between these two terms, I can factor AB out. What is left is A plus B, and this is 56. So this is now my question mark, but AB is given to be 1 and A plus B is given to be 4. So this becomes 4. If I move it to the right-hand side, I would definitely get immediately my question mark. So this is 52. Okay. Now I go to A to the power of 4 plus B to the power of 4. So you see here in this formula, what I do, I replace the box with A squared and I replace the circle with B squared. And then what I will get is this. If I put this here, this becomes A to the 2 to the 2, which is A4 plus B to the 2 is B4. And then I have A squared plus B squared to the 2 minus 2A squared B squared. Yes? This is my question mark now. I have already calculated A squared plus B squared. Here it's 14. So I plug it here. So it's 14 to the 2 minus, instead of this expression, I can write AB to the 2. But AB is 1. AB to the 2 is also 1. So it becomes minus 2. And then you see this is 196 minus 2, which is 194. So then it means that A to the 4 plus B to the 4 is 194. Yes? And if I go to the for A to the 4 minus B to the 4, so if you don't mind, let me clean this because I would need that one. And yes, I will also need this one. So let me clean these two parts. So A to the 4 minus B to the 4 actually forms a conjugate pattern for me. So I can factorize it once using the conjugate pattern, so it becomes this. But I can also factorize this one more step, so it becomes a minus b, a plus b, then I have a squared plus b squared, yes? So what is left for me? A minus b I calculated to be 2 square root of 3 multiplied. A plus b was given from the beginning, which is 4. And then a squared plus b squared I calculated here. It's also 14. So what happens if I multiply them? So this is 8, and this is 112 square root of 3. So that is the answer to a squared minus b, a to the 4 minus b to the 4. And now, what can I do here for this one? Let me use the formula here on the board, but with a different substitution, yes? So let me clean this one now. Here, I would say that I would replace the box with the 4th root of a, and I would replace the circle with the 4th root of b, yes? Then I will have this situation. If I replace these things here, this becomes the 4th root of a to the 2 plus the 4th root of b to the 2 is equal to the 4th root of a plus 4th root of b, totally to the power of 2, minus 2 4th root of a times 4th root of b. But you know that the 4th root of a to the 2 is nothing except square root of a. And this is also square root of b. It's equal to this 4th root of a plus 4th root of b to the 2 minus 2. Instead of this expression, I can write the 4th root of the product, ab. But what is my question mark here? This is my question mark now. But I have already calculated, if you look back at the video, I already calculated the square root of a plus a square root of b, and I got a square root of 6 for this. So what I got for this is a square root of 6. I solved this problem in the first part. And this is exactly my question mark. So this is question mark to the 2, yes? And then I have minus 2 because AB is 1 given in the problem. 4th root of 1 is 1 multiplied by 2 is 2. So what I need to do is that I have question mark squared. I move 2 to the left-hand side, so it becomes 2 plus square root of 6. And then I want to find my question mark, so I need to take square roots from both sides. But of course, then you will have two answers, plus or minus square root of 2 plus square root of 6. But again, it is clear that the output of the 4th root is a non-negative number, so this is a non-negative number, so the negative answer is not acceptable. So what I get is that the question mark is positive square root of 2 plus square root of 6. I really don't need to write that one, okay? I hope that this is somehow clear. Okay, now I go to the next problem. So let me clean this. Okay, so the second problem, part B, so let me clean everything here now. So the second problem, I have x and y real numbers, x and y belonging to the set of real numbers. And then I have been provided by xy equals to 3, and I have this expression x squared y plus xy squared plus 2x plus 2y equals to 25. And I am supposed to answer this question. What is x squared plus y squared? Okay. This is fairly simple, yes? So for example, if you look here, between these two terms, I can factor xy out. What is left for me is x plus y. Between these two terms, I can factor 2 out. What is left is x plus y, and on the right-hand side, I have 25. But I can use this information that xy is 3, so I replace this xy with 3. So then I will get 3x plus y plus 2x plus y is equal to 25. Yes, so I have 3x plus y plus 2 more of the same thing, so it becomes 5x plus y equals to 25. And then I can divide by 5, it becomes x plus y equals to 5. So I have x plus y equals to 5 and xy is equal to 3. Again, I can use my famous identity. X squared plus y squared is x plus y to the 2 minus 2xy. This is the question mark in the problem, and I have got x plus y is 5, so it becomes 5 to the 2 minus 2 times xy, which is 3. So this becomes 25 minus 6, which is 19. Okay? Hopefully that is also clear for you. Okay, now I go to the next problem. This is more interesting. It's mentioned that x is a positive real number, so x belongs to R. It's a real number, but it is also positive. And what I know is that x squared over x to the 4 plus 1 is 1 over 7. My question mark in this case is x to the 3 plus 1x to the 3. Yes, this is my question mark. Okay. So what I do here is that when x squared divided by x to the 4 plus 1 is 1 over 7, I can say that the reciprocal of this fraction means if I swap the numerator and denominator, x to the 4 plus 1 divided by x squared is definitely 7 over 1. Yes? I'm just interchanging the denominator and numerator of the first one, so I have to do the same thing for the second one, so to be able to keep the equality. Okay, but you know that I can write it in this form. The left-hand side can be written as x to the 4 divided by x squared plus 1 divided by x squared. And of course, 7 over 1 is just 7. But x to the 4 divided by x to the power of 2 can be simplified. The better name for this is x to the 2. And then I have 1 over x to the 2 is equal to 7. But of course, you see that I want to find a connection between this and x to the 3 plus 1 over x to the 3. By the experience that you have got so far, probably you would say that this is probably not doable in a proper way. So what can I do is to use a trick. How can I find x plus 1 over x from this? The trick is add 2 units to both sides. You will see why. X squared plus 1 over x squared plus 2, it becomes 9. Because I added 2 units to both sides. Why this is good? Because if you have a keen observation, you can immediately recognize that this is the quadratic pattern. Yes? So how is that? So this becomes x plus 1 over x to the 2 is equal to 9. Okay? So let us justify this for you. 9 and equality are the same, so I just copied and pasted them there. But do you believe that this is exactly equal to this? Let us check. According to the quadratic rule, this is the first one to the 2, which gives me x squared, 2 times the first one times the second one. So you see, 2 times the first one times the second one. But this x and x will cancel, so it becomes just 2. So 2 times the first one times the second one is just simply this 2, and then the second one to the power of 2 is this one. So what I have done is completely valid. But then I have something to the power of 2 is equal to 9. There are 2 possibilities for 1 over 1x, positive or negative 3. But of course, you see that x is supposed to be positive. If x is positive, 1 over x is also positive, and if I have two positive numbers, the sum is also positive. So the negative answer is not acceptable. So this means that since x is positive, I can say that 1 plus 1 over x is just 3. Okay, now let us look at these two. I have this x plus 1 over x is 3. I have x squared plus 1 over x squared equals to 7. So I can use the same trick. Probably you know. I multiply both sides. Yes? If you have watched the video, you can see that we talked about these kind of tricks a lot. So here, I would say that, let me write them here for you. 1 over x plus 1 over x is 3. And then I have x squared plus 1 over x squared is 7. So now I multiply both sides. I multiply this by that, so it becomes 1 over 1x multiplied by x squared, 1 over x squared. And if I multiply these two, it becomes 21. Yes? And then I start multiplying it. So I would write here, x times x squared is x cubed plus x times 1 over, let me write the details, x times 1 over x squared plus, I multiply this by that, 1 over x multiplied by x squared plus 1 over x multiplied by 1 over x squared becomes 1 over x cubed. And on the right hand side, I will have 21. But then let us see what happens. X to the power of 3 plus 1 over x to the power of 3 is my question mark. So let me write them next to each other. But what is happening here? One of these x's and one of these x's are simplified, so I will get 1 over x. But then again, the same story. X and x is cancelled, so I am left with 1x. On the right-hand side, I have 21. This is my question mark. X plus 1 over x, I just got it here. It's 3, yes? So I just plug it here, so my question mark plus 3 is equal to 21. It's easy to see that the question mark I am looking for is 18. Okay, and now finally, I want to solve the most challenging problem in the problem set here. I think everything is clear, yes. So I go to part D, but probably I will need all the board. So if you don't mind, please let me clean everything that I have written so far. So I can start from here. Okay. So let me explain this. So part D is this problem. So A, B, X, and Y are real numbers. So A, B, X, and Y are real numbers. And we know this. We know that A plus B is 5. I know that AX plus BY is 4. I know that AX squared plus BY squared is 14. And I know that AX cubed plus BY cubed is 22. And then the question mark is that what is AX4 plus BY4? Okay, so you might have some kind of experience here. You might think that it is a good decision to multiply these two side by side, but this is not a good idea. Because if I start multiplying this expression by that expression, I will not get something similar to this so that I cannot use this information. Because A will be multiplied by AX, then you will get A squared X. But what you need is actually AX squared. So this usual method that we have used in the lecture and also sometimes here in these problems, you shouldn't expect that this is going to work. So you need to be a little bit smart and stubborn to try to add the new methods. Okay, so one method that I could come up with is I want to explain it here for you. So I would say that here I have ax plus by is equal to 4. Yes. I multiply everything on both sides by x. So then I will get ax squared plus bxy, and I have 4x on the right. I also multiply both sides by y this time. Then I will get axy plus by squared is equal to 4y. Yes. So you see, this is a good thing to do because now you see I have ax squared and by squared. These are exactly the combination that I need. But of course, you see I need the sum of these two terms. So it might motivate you now that you have them in a correct, more or less the correct form, you can add them side by side. So then I would write ax squared plus by squared next to each other. So this becomes ax squared plus by squared next to each other. And then here and here, I can factor, I have to add this term and that term, but both of them share xy in common, so I factor it out, so it becomes plus a plus b xy. On the right-hand side, I have 4 in common, so when I add them, I take this 4 out. But you see, a plus b is given in the problem to be 5. This is also given in the problem is 14. So this is 14. So I get one relation. It's 14 plus 5xy is equal to 4 times x plus y. Let me keep it. Okay? More or less, I want to do the same thing. So I started from this one. Now I will start this from this one and do the same thing. So I will start here. Ax squared plus by squared is 14. I multiply both sides by x. It becomes ax cubed plus bxy squared is 14x. Once more, I multiply both sides by y. So then it becomes ax squared y plus by cubed is 14y. And then I add them again. Add them side by side. So here I added, here I also add. Then this one and this one can be written next to each other. So ax cubed plus by cubed. And then here and here, I have a factor of x, y in common again, so I can factor it out. But this time, what is left is, this is ax plus by in brackets, and then I have xy. On the right-hand side, when I add them, 14, I can factor it out, so it becomes 14x plus y. Now let us see what happens. This one is given in the problem to be 22. So this is nothing except 22. But what is this one? This is also given in the problem to be 4. So if I substitute these things, what I get, I can write it here. So this becomes 22 plus 4xy is equal to 14x plus y. And if you don't mind, all of them are divisible by 2, so let us divide them by 2. So it becomes 11, 2xy, and it's equal to 7x plus y. Yes, so this is another relation. Now look here. I will call this one number 2, and I will call this one number 1. So if you broaden your perspective, you immediately see that this 1 and 2 will form a system of equations for me, but my unknowns are x, y, and x plus y. So might be it motivates you that let us give them a name. xy, I call it u, for example, and xy, I call it v. Then number 1, this number 1 equation would be 14 plus 5v is equal to 4 times u. And that equation number 2 will read 11 plus 2v is equal to 7u. And that is just a simple equation that I need to solve for u and v. Yes? So for example, if I want to solve it, I can multiply this by 2. I can multiply this by negative 5. So let us see what happens. So then this becomes 28 plus 10v is 8u. This becomes minus 55 minus 10v is minus 35u. And now if I add these two together, this minus 10v and 10v are gone. So how much is left here? It's negative 27, yes? So it's negative 27 is equal to it's negative 27 as well. Yes? And then you can immediately see that u becomes 1. When u is 1, I can replace u, for example, in that equation. Then I will get 14 plus 5v is equal to 4. Then you can immediately get that v is how much? It's minus 2. Okay, so what does it mean? U was x plus y, so far I know that x plus y is 1, and I know that x times y is minus 2. So this is what I got so far. But now finally, I want to go to this question mark. I again do the same process here. So I would say that ax cubed plus by cubed is 22. Again, I multiply this by x on both sides. It gives me x to the 4 plus bxy cubed is 22x. And then once more, I multiply everything, both sides by y. So this gives me x to the 3y plus by to the 4 is 22y. And then again, you see, I am just using the same trick over and over again. I add them, this one and this one, I write next to each other. So it becomes ax4 plus by to the 4. And this one and that one, when I add them, I see if xy in common. So if I factor xy, it becomes ax squared plus by squared xy. And if I add these two, it becomes 22x plus y. Now I think that you have realized what is happening. This is exactly the question mark. So the question mark plus this one is 14 given in the problem multiplied by xy. I just got it right now. It's minus 2. On the right hand side, I have 22 multiplied by xy, but xy is just simply 1. Yes? So then you see that the problem is solved. The question mark is simply 22. And then here I have minus 28. I move it to the right hand side, it becomes positive 28. And then the answer becomes 50. Okay? I hope that this is helpful for you. I really would be interested if I see any comments or any suggestions, objections about improving the videos. I would be very thankful if you just leave a comment. How can I improve these videos so that it benefits more people? Okay, I will also put a link again to the questions below this video again. So if you want to have the questions, you can also download it from that link. Thank you very much. Bye.